where first I'll explain you basics of SONET, then we will see SONET devices, then I'll explain you structure of SONET, then we will see operation of SONET, then I'll cover frame of SONET, and then I'll explain SONET network, and for that I'll be covering ring SONET, and then we will see SONET applications. So let us begin this session with first agenda, that is basics of SONET. Now when we talk about SONET or SDH, SONET is actually synchronous optical network. So full form of SONET is synchronous optical network. It is optical transmission interface, and it was proposed by Bellcore Laboratories and was standardized by American National Standard Institute (NC). So it was proposed by Bellcore Laboratories and standardized by NC. A compatible version of that is SDH, synchronous digital hierarchy. So you will be finding SONET oblique SDH is been written. Both are having same purpose. Only compatible version of SDH is what? SONET. So the major goals of SONET is, SONET being synchronous network requires a single clock to handle timing synchronization and equipment across the network. So the basic agenda is to provide timing synchronization. There should be standardization of fiber optic transmission system equipment sold by different manufacturer. So if standardization is there, in that case different manufacturer can fabricate and sell equipments based on pre-specified standards. So there is a need of standardization. So SONET is what one standard which is justifying how we will be transmitting signal in optical network, and for that complete standardization that has been done by NC, and that will be even helpful to different manufacturer to design different components for optical network. The physical simplification and frame design must include mechanism that will allow it to carry signals from incompatible tributary system. So there is a need of frame designing. So I'll explain you frame designing of SONET. So that explains you how we can provide synchronization in between different systems. SONET is multiplexed transport mechanism, hence it can be the carrier for broadband services such as ATM and BISDN. So it is what? Multiplex transport mechanism. So we can have interface of SONET with some other services such as ATM and BISDN. SONET is basically functioning based on time division multiplexing. So we will see that in detail with frame. So it will be clear like how SONET is functioning. So let us try to understand that by first of all how many devices are there. So basically there are three categories of three basic devices are there. One is STS multiplexer. STS multiplexers means what? It is synchronous transport signal multiplexer. So this multiplexer, those are synchronous with respect to time. Second device, that is regenerators. So regenerators, that is been utilized to regenerate the signal, and as if you regenerate the signal, then it is possible to connect transmitter and receiver for long distance communication. So regenerators, those are so essential in SONET network. And third device, that is add drop multiplexer. So this is to add and drop any channel in between somewhere in network so that we can increase capacity of optical network. So add drop multiplexer, regenerator and STS multiplexers are there in SONET devices. You can see SONET structure where here we have terminals. Those terminals could be transmitter or receiver. Over here even there are some terminals. Those could be transmitter or receiver. Here there is STS mux demux. So that is to multiplex and demultiplex channel with synchronization of timing, and then we are sending it over fiber. There are regenerator in between fiber, that is to regenerate the signal so that we can send signals to very long distance, and in between somewhere there could be add drop multiplexer. So add drop multiplexer is to add and drop channels in between somewhere in the network. So this is how interface of SONET is there, and that is having complex communication as well as long distance communication because of these three major elements: STS, multiplexer, regenerator, and add drop multiplexer. So this is what the structure which is there with SONET. Now let us discuss how SONET operates. So the STS multiplexer or demultiplexer used for two purposes. One is multiplexing and second is demultiplexing. Multiplexing is happening at input terminals, so it will combine signals, and demultiplexing, that is happening to separate channels. And here STS multiplexer is used, so that is having synchronization of multiplexed channel with respect to time. So STS signal passes through number of regenerator and repeater while it is traveling from source to destination. Regenerator are basically repeater, and that is bidirectional device so that it can function in both of the direction. They will regenerate STS applied to them, and this will eliminate any additive noise which is happening so that it can improve quality of transmission. SONET regenerators function as data link layer. See, add drop multiplexer is capable of adding signals from various sources, and it can remove signal and redirect demultiplexed entire multiplex signal. So it will be redirecting that by adding and removing channels if it is required in between somewhere, and this is how basic operation which is happening with SONET. Now I'll explain you frame of SONET. Now you can see the complete frame that is having 9 rows, and each row is having 90 bytes. So SONET frame that is having 9 rows, each rows that is having 90 bytes, and first 3 bytes of all 9 rows, those are transport overhead. So first 3 byte of each rows, that is transport overhead. So you can see that is given over here. This is transport overhead, and transport overhead again divided into two categories: section overhead that is having 3 rows, and 6 rows that is there with line overhead. And 87 bytes of 9 rows means 87 cross 9, that is what information payload. So information payload that is there with the data quantity of 87 bytes for 9 rows. So 87 cross 9, so that many number of information payload is there in single frame, and each frame that we transmit with the data with the time period of 125 microsecond. So each frame that we send it with the period of 125 microsecond. So this is what about SONET frame. So see, it has total 3 cross 9, 27 administrative overhead. It has 87 cross 9, that is 783 bytes of information. Administrative overhead is again bisected into two parts. Section overhead that is 3 cross 3 means 9 byte, and line overhead that is 3 cross 6, that is 18 byte. Here section overhead that is to have framing, error monitoring and management of functions, and line overhead that provides synchronization, multiplexing and protection switching. So this is how administrative overheads are there, and frame period is 125 microsecond. So for SONET data rate, if you calculate this 8 cross 9, 8 is for number of bits, so 1 byte is equals to 8 bits into 9 rows into 87 bytes in each row divided by 125 microsecond. So the data rate that will be 50.122 Mbps. So SONET is having data rate of one channel with 50.122 Mbps. You can see SONET network here with SONET ring. So here add drop multiplexers are there, that is to add and drop any channel in between somewhere in the network, and this is the ring. If you see this ring, that is again subdivided into two categories. One is working rings and second is protection rings. working ring that is transmitting this signal from one terminal to other terminal. But if any failure is happening, in that case this protection ring will come into the picture, and that will re-establish routing protocols from transmitter to receiver. So in SONET network, SONET ring, it is having working rings and protection ring. Working ring is to have normal translation of connection in between transmitter to receiver, and in case of failure of any link you can have protection rings, so that will reconnect routing in between transmitter to receiver without any disturbance. So this is the basic structure which is there with SONET ring. There are some other network even, but I have explained this SONET ring to make it clear like how SONET network functions. These are the basic applications of SONET. You can use it in ISDN and BISDN network. It can be used as a carrier in ATM cell. It can be used based on bandwidth on demand. SONET can be used for cable TV network, and in T1 and T3 carrier lines we can use SONET. So these are the basic applications which is there with SONET, and this is making use of SONET so popular in the market. I hope that you have understood this session. Thank you so much for watching this video. You can give your valuable suggestions. Definitely based on your suggestions in future I'll make videos which will be solving all the queries which is required to be solved here on my channel, and that will be helpful to students learning from my channel. So please do give your valuable suggestions. Definitely your suggestions are most welcome to me. Please give it over here, and that will optimize this channel. Thank you so much for watching this video.